last class we completed question number 4. This class we will start question number 5 onwards. So question number 5, what is given? We are going to differentiate this function. So we can take it as y, that is sine of, differentiate sine of ax plus b divided by cos of cx plus d. We are going to differentiate this function with respect to x. So we have to apply the u by v rule. Quotient rule we studied. What is quotient rule? U by v whole dash equal to u dash v minus u v dash divided by v square. So I am going to apply that. I can find this, we have to take it as u, numerator, denominator we have to take it as v. So find u dash means differentiation of numerator. Differentiation of numerator means differentiation of sin x equal to cos of ax plus b. Then again differentiate x in the place. What is that? Ax plus b. So differentiation of ax plus b with respect to dx means differentiation of ax plus differentiation of b. So what you will get? Differentiation of ax is a, differentiation of b is 0. So a will be multiplied a into cos of ax plus b. Similarly v dash we have to find. V dash means differentiation of cos x, differentiation of v had, this is v taken as v, differentiation of cos x is minus of sin x. So minus of sin of cx plus d into d by dx of x in the place what is there? Cx plus d. So differentiation of cx plus d with respect to x is c. So we will get minus of c into sin of cx plus d. So I have found the value of u dash and I found the value of v dash. Now I can apply that into the formula. So what will come? What is y dash? Y dash equal to u dash. U dash value is a into cos of ax plus b into v, u dash v. So remaining cos of cx plus d minus u into v dash. What is the value of u? U is sin of ax plus b into v dash value is minus c. So it will become plus c into sin of cx plus d. Sin of cx plus d. Sin of cx plus d whole divided by, denominator is v square. So v square means we have to write as cos square cx plus d. Next we have, so writing the denominator separate, numerator separately. So writing first term means I will get a into one of the cos of cx plus d will cancel. So remaining one of the cos cx plus d will be remaining. So I am writing as cos of cx plus d. Here this c constant will be written before, remaining we have to write as it is. So sin ax plus b will be as it is sin of ax plus b. With this what will be multiplied means sin of cx plus d will be multiplied, denominator will be cos square cx plus d. Next what I need to do? I need to simplify still. So how we can simplify means the 1 by cos I can write it as secant. So a into cos of ax plus b into secant of cx plus d, second term, c into, see numerator first term it is not possible to simplify, so I am writing as it is sin of ax plus b. Second time one of the cos I can simplify, remaining one of the cos I need to keep as it is. So sin by cos equal to tan, so that I am writing tan of cx plus d, remaining 1 by cos will be there, that is 1 by cos equal to secant, so that I am writing secant of cx plus d. This is the derivation of differentiation or derivative of the given function y equal to sin ax plus b by cos of cx plus d. Next question. Next question, y equal to cos x cube. Question number 6. Y equals to cos of x cube into sin square x power 5. sine square x power 5. So it is multiplication of two functions. So we have to use UV rule, product rule, or Leibniz rule. UV rule we have to use, that is our product rule we can say, or Leibniz rule that we can say. So what is the product rule? UV whole dash equals to U dash V plus UV dash. Differentiation of first function into second function plus first function into differentiation of second function. So this I need to consider as first function, this I need to consider as second function. So we can take it as U equal to cos of x cube. So differentiation, that is U dash equal to differentiation of cos x, this composition of two functions, cos function and x cube function. So first to differentiate cos function, that is differentiation of cos x equal to minus sine of x cube. Again d by dx of x cube, x in the place x cube available, that we have to differentiate and multiply. So d by dx of x cube is 3x square. So simplifying this, I will get minus 3 times x square into sine of x cube. This is my u dash. What is the value of v dash? Similarly, v dash equal to, let v equal to what we have taken, you can write here. So v equal to sine square x power 5. So it is a composition of three functions, square function, sine function, x power 5 function. So I need to apply the chain rule 3 times. So v dash equal to, first use the power function, differentiation of sine square x equal to 2 times sine x. That is, I have used here x power n formula, d by dx of x power n, d by dx of x power n equal to n into x power n minus 1. This formula I have used. So that same method I am using, means sine square mean differentiation of sine square equal to 2 sine x into d by dx of x in the place, what is that? Sine of x power 5 is there. So differentiate this and multiply. So 2 times sine of x power 5, 2 times sine of x power 5 into d by dx of sine x. Here it is composition of two functions, sine function and x power 5 function. So differentiate sine first, that is cos of x power 5. Again differentiate x in the place, what is available? X power 5. So that x power 5 will be multiplied here. What is the differentiation of x power 5? 5 into x power 4. So already 2 there. So 10 times x power 4 sine x power 5 into cos x power 5 is the answer for v dash. Okay, so now we have found the value of v dash. So now then what we have to do, we have to apply into the formula uv, the whole dash we have to apply. Clear up? So now apply into that, what will come? Uv dash, that is y dash, we can write it as u dash v, that is minus 3 into x square into sine of x cube into v value is what? V value is sine square x power 5 plus u v dash, u value is cos of x cube into v dash value is 10 into x power 4 sine of x power 5 into cos of x power 5. Now I have to write in correct order. So what does the correct order mean? Positive term will be first, negative term will be second. So I am writing this as 10 into x power 4, this term 10x power 4 sine of x power 5 into cos of x cube into cos of x power 5 minus second term 3 times x square into sine of x cube into sine square x power 5, which is the derivation of the given function y. This is the derivative of the given function. Clear? Next question number 7. Y equal to 2 into root of cot x square. So question number 7, what is given? Y equal to 2 into root of cot x square. So it is composition of how many functions? Root function, cot function, x square function, 3 functions. So we have to apply chain rule. So y dash equal to 2 into, or first we rewrite this 2 into cot of x square power 1 by 2. Clear? So now apply the differentiation now. So 2 into some x power 1 by 2. Differentiation of x power 1 by 2 is 1 by 2 into x power, that is cot of x square power 1 by 2 minus 1, that is minus 1 by 2. And again x in the place, what is there? Cot of x square is there, so that we have to differentiate and multiply. So d by dx of cot of x square. Clear? So now differentiate, cancel this, differentiate this, so this will come to denominator. So 1 by root of cot of x square, this d by dx of cot x. What is the d by dx of cot x? It is minus cosecant square x. So minus of cosecant square x square into d by dx of x square, because it is composition of two functions, cot function and x square function. So again I need to apply the chain rule. So now we have to differentiate this and we will multiply this inside before that. So differentiation of x square is 2x, so already minus there, so minus of 2x into cosecant square x square divided by root of cot of x square. Clear? This is the question answer for this derivative of the given question, but we have to get the book answer, so we need to simplify this. So simplify this. So how to simplify? The cosecant square will go to denominator. So cosecant square will go to denominator, means that is sine square. So I am writing this as sine square into x, sine square x square. This cot of x square can be written as root of cos x square divided by sine of x square, cot x square divided by root of sine x square. So this I can write in here minus 2x divided by sine square x square into this I can write sine of x square power minus 1 by 2, or this I can write as the power 2 into what will be remaining, root of cos of x square will be remaining. This I can simplify, combine these both, I will get minus 2x divided by, combining both I will get 2 minus 1 by 2, 3 by 2. 3 by 2 means that I can write sine of x square into root of sine of x square. Already root of cos x square is there, so I am merging with that, writing cos of x square. So what I am going to do, I am going to multiply the root 2 in the numerator and denominator to simplify more. So I am multiplying root 2 in numerator, denominator also multiplying by root 2. The root 2 also will be combined with this. So numerator will be minus 2 root 2x divided by denominator, that root 2 will be written inside the root. So root 2 is writing inside, means this root 2 will be combined with this 2 into sin x square cos x square. We have formula for sin 2x. Sin 2x equal to 2 sin x cos x. So this 2 will be multiplied inside, means 2 sin x square cos x square means sin of 2x square. So already outside what is there? Sin of x square is there. Inside that root, sin of 2 times x square will come. This is the simplified form of the given question, and also we simplified our answer that is given in the book. Next question number 8. Question number 8, what is given? Differentiation of cos of root x. Very simple problem. So question number 8 is given. Question number 8, y equal to, it is given that cos of root x. It is composition of two functions, so I need to apply the chain rule while calculating the derivative. So dy by dx or y dash, whatever it is, we can write. So dy by dx equal to differentiation of cos x equal to minus sin x. So minus of sin of root x into d by dx of root x. So what is differentiation of root x? Differentiation of root x, I have already studied. I told we have keep it as a formula. So if you don't know also no problem. This will be differentiated means 1 by 2 into x power 1 by 2 minus 1. So this will be written as sine of root x into the 2 will be written in denominator x power 1 by 2 x power minus 1 by 2 going to denominator means that is x power 1 by 2, that is root x. So d by dx of dy by dx equal to sine of root x divided by 2 root x, or we can take it as y dash also. This is the derivative of the given function. So before entering into question number 9, we have to recall the definition that we have studied in the last class. That is, I told that let LHD and RHD. So left hand derivative of the function at x equal to a, f dash of a equal to limit h tends to 0 f of a minus h minus f of a divided by minus h. This left hand derivative. What is right hand derivative? RHD f dash of a equals to limit h tends to 0 f of a plus h minus f of a divided by positive h. This is the left hand derivative and right hand derivative definition. We are going to use this definition for the problem 9 and 10. Okay, question 9. Prove that the function f is given by f of x equal to modulus of x plus 1. So f of x equal to modulus of x minus 1 is not differentiable at x equal to 1. So it is not differentiable at x equal to 1, we have to prove. Not differentiable at x equal to 1 means at x equal to 1 LHD and RHD is does not exist, or we can say LHD and RHD existing and both are not equal, we need to prove. Clear? So now use the definition of LHD and RHD at x equal to a. We have written the definition of LHD and RHD. So the given value equal to 1. So a value is equal to 1 here. Now find the derivative of the function, a left hand derivative. So what is LHD? LHD, that is f dash of 1 equals to limit h tends to 0 f of 1 minus h minus f of 1 divided by minus h. So I need the value of f of x and I need the value of f of 1 minus h, everything. So what is the definition of modulus of x here? Definition of modulus of x minus 1 is positive x minus 1, x is greater than or equal to 1. Clear? Negative of x minus 1 if x is less than 1. It is LHD case, that is left side of 1. So I need to use f of x equal to negative of x minus 1. So my f of x value is minus of x minus 1. Multiply minus inside means 1 minus h. So f of x equal to 1 minus h. What is f of minus x? What is f of 1 minus h? Now replace x in the place 1 minus h. So 1 minus h I am replacing. Multiplying minus inside means 1 minus 1 plus h will come. So f of 1 minus h is equals to h. Clear? So what is the value of f of 1? F of 1 I am applying means x in the place, replace 1. So I will get 0. So now find the LHD. So LHD equal to f dash of 1 equals to limit h tends to 0. F of 1 minus h value equal to already found h. F of 1 value equal to 0 divided by minus h will come. So h by minus h minus 1 will come. So my left hand derivative, that is limit h tends to 0 is minus 1. So LHD equals to minus 1. We are getting our LHD equal to minus 1. Now we have to write the RHD. I think it is hiding. LHD equal to minus 1. I am writing here itself. Equal to minus 1. This is our LHD. Clear? So now we have to find the RHD, right hand limit. So what is right hand limit? So right hand derivative, definition of right hand derivative written here. So right hand derivative case, What is the f of x value? So f of x value in right hand derivative case is x minus 1. So now apply the right hand derivative RHD. Before that we can write RHD equals to RHD at x equal to 1 I need to find. So f dash of 1 is equals to limit h tends to 0 f of 1 plus h minus f of 1 divided by positive h. So in this case, what is the value of f of x? Greater than 1 case, f of x is x minus 1. So f of 1 plus h means substitute x in the place 1 plus h. So 1 plus h minus 1. Here also I am getting the value is equal to h. F of 1 plus h equals to h. F of 1 value equal to 0. Now apply this both values f of 1 plus h and f of h value into the RH definition f dash of 1. So f dash of 1 equals to f dash of 1 equal to what will come? Limit h tends to 0 f of 1 plus h value I found h minus f of 1 equal to 0 divided by positive h. So simplifying means we will get limit h tends to 0 h by h will come, that is equal to 1. So my LHD equal to minus 1 already I found, and RHD equals to positive 1. So clearly we can say LHD is not equals to RHD, at which point at x equal to 1. So therefore f of x is not differentiable. F of x is not differentiable at the point x equal to 1. Clear? Next question number 10. Question number 10. Prove that the greatest integer function, question number 10, f of x equals to greatest integer of x. Prove that the greatest integer function f of x equal to the greatest integer of x defined on 0, x is greater than 0, less than 3 is not differentiable at x equal to 1 and x equal to 2. We need to prove that it is not differentiable at x equal to 1 and x equal to 2. Already we studied that it is not continuous at x equal to 1. We proved it is continuous at x equal to, that is, it is not continuous at every integral points we proved. So same thing we are going to use here, LHD and RHD. Two ways we can use this. We can prove the continuity. We are proving continuity means we failed to prove continuity at x equal to 1 and x equal to 2. So we can say that the function is not continuous. From that we can say every continuous function, okay, every differentiable function must be continuous, but this function is not continuous at x equal to 1 and x equal to 2. We can say that it is not differentiable. Another way is using the LHD and RHDs, that we can use left hand derivative, right hand derivative at x equal to 1. We are going to show that both are not equal. Similarly, left hand derivative and right hand derivative at x equal to 2 also not equal. We are going to show now. So first we will prove the differentiability for x equal to 1. We are going to check that. So LHD, left hand derivative at x equal to 1, we are going to find left hand derivative. So what is the definition here? F dash of 1 equal to limit h tends to 0 f of 1 minus h minus f of 1 divided by minus h, or we can write that LHD and we can use that. What is LHD definition? Limit x tends to 0 f of a minus h minus f of a whole divided by minus h. This is the definition of LHD. Next we will use the write the definition of RHD. What is definition of RHD now? Definition of RHD equal to limit, not extends, that is h tends, limit h tends to 0 f of a plus h minus f of a divided by positive h. So in this case f x equal to 1 we are going to take. So what is the value of f of x here? F of x equals to greatest integer of x. Clear? So I need the value of f of 1 minus h. So f of 1 minus h means greatest integer of 1 minus h. As I said already, h value is very small value. That is very small value, or we can take it as approximately very small value. That, for example, we can take h equal to 0.1, like that I am considering. So what is the value of 1 minus 0.1? 1 minus 0.1 mean that will be 0.9. So for that greatest integer I am taking mean that will be equal to 0. So use that here, greatest integer of 1 minus h, that is equal to 0. What is the value of f of 1? F of 1 means x in the place replace 1, greatest integer of 1 equal to 1. So now apply these values into the LHD definition. So f dash of 1 is equals to limit h tends to 0, f of 1 minus h value is 0 minus 1 divided by minus h. That is equal to, simplifying, limit h tends to 0 minus 1 by minus h equal to 1 by h. So limit h tends to 0, 1 by h is equals to infinity. So I am getting the LHD equal to infinity. So let and limit equals to infinity. What about RHD? Definition of RHD we have written. So use that here. So RHD, right hand derivative at the point x equal to 1. So f dash of 1 equals to limit h tends to 0, f of a plus h, that is 1 plus h, f of 1 plus h minus f of a value is 1 divided by positive h. So what is the value of f of x here? F of x is nothing but greatest integer of x. F of x equal to greatest integer of x. So now what is the value of greatest integer of f of 1 plus h? So I need to replace x in the place 1 plus h. H value is very small value, it is very close to 0. So I am considering h equal to 0.1 here. So 0.1 means what is 1 plus h? That is 1 plus 0.1, 1.1 will come. So greatest integer of 1.1, there is no change, as it is 1 only will come. So we can take it as 1 is the greatest integer of 1 plus h. That is f of 1 plus h value equal to 1. So what is the value of f of 1 now? F of 1 means that is same as greatest integer of 1, that is equal to 1. Now apply these values in the RHD. So f dash of limit x, f dash of 1 equal to limit h tends to 0, f of 1 plus h value is 1 minus f of 1 value is 1 divided by positive h. So numerator is 0, so we will get the limit as 0. So clearly our RHD is equals to 0. So LHD equal to infinity, RHD equal to 0. So what we can say clearly? The function, that is f of x, is not differentiable at x equal to 1, because one more step we can write LHD not equals to RHD. So f of x is not differentiable at x equal to 1. Similarly, we have to prove f of RHD not equal to 0 now. We will prove x equal to 2, it is not differentiable. We will prove now. Second part of the proof. So LHD at x equal to 1, we will x equal to 1 we proved. Now LHD at x equal to 2 we are going to see. LHD at x equal to 2. So f dash of 2 equal to limit h tends to 0, f of 2 minus h minus f of 2 divided by minus h. So what is f of x? Our f of x equal to greatest integer of x. So I need the value of f of 2 minus h, that is greatest integer of 2 minus h. So what is greatest integer of 2 minus h? Already we studied h value equal to 0.1. So subtracting small value from 2, we will get 1.9. So greatest integer of 1.9 equal to 1 only will come. So whatever, because the value of h equal to very small, so the 2 will be reduced to 1.9 or 1.99 9 something will come. So greatest integer of that value equal to 1. So f of 2 minus h equals to 1. What is the value of f of 1? F of 1 sorry, f of 2. F of 2 we have to find. F of 2 equal to greatest integer of 2, that is equals to 2. Now apply in the definition. F dash of 2 equal to limit h tends to 0. F of 2 minus h equal to 1. F of 2 equal to 2 divided by minus h. So we will get limit h tends to 0 minus 1 by minus h equal to 1 by h. So we will get our LHD equals to infinity. Clear? LHD equals to infinity we will get. Now we have to find the RHD by using the definition of RHD. So what is the definition of RHD? That is already we have written f of limit h tends to 0, f of a plus h minus f of a divided by h. So use that now at RHD at the point x equal to 2. So what will come? F dash of 2 equals to limit h tends to 0, f of 2 minus h, here will come 2 plus h minus f of 2 divided by positive h. So what is the value of f of x here? F of x equal to greatest integer of x. Similarly, what is the value of f of 2 plus h means greatest integer of 2 plus h. So what is the value of greatest integer of 2 plus h? H value is very small. If you are adding, for example, h equal to 0.1 means 2.01 will come. So greatest integer of 2.01 will be 2. So clearly f of 2 plus h equals to the value equal to 2. Now what is the value of f of 2? Now f of 2 is greatest integer of 2. Greatest integer of 2 also equals to 2. Now apply in the definition of RHD. So f dash of 2 is equals to limit h tends to 0, f of 2 plus h value equal to 2, f of 2 equal to 2 divided by positive h. So I will get limit h tends to 0 is equal to 0. So my RHD equals to 0. Our LHD equal to infinity, RHD equal to 0. So clearly LHD not equals to RHD. LHD not equals to RHD. Therefore we can say f of x is not differentiable at the point x equal to 2. Suppose the given function is given that only restriction given that x value is greater than 0, less than 3. Suppose it is given x is greater than 3, less than 6 means we need to prove prove that the function is not differentiable at x equal to 4 and 5. So we have to replace 4 here. We have to do as usual method. Similarly 5 we have to use here. We have to as usual method. Always we will get LHD equal to infinity, RHD equal to 0, LHD not equal to RHD only we will get. Clear? Okay. Remaining second exercise we will start in next third exercise we will start in next class. Thank you all.